From Chicago, welcome to 3 Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
So coming from a tooling background, it always started with a 2D print, and we would basically sit down and we would lay that out, and then build basically, from a 2D print. Then when I started managing our CNC department, we started getting into 3D rendering, surface modeling, and we really thought that was, in the early to mid 90s, that was really, intense technology. But now to be able to take a solid model and then basically within a day, we can basically take that solid model, we can pull the inverse of that all in CAD and basically skip all of those steps.
That was Brandon Lamoncha. Brandon is the head of Additive Manufacturing at Humtown Products in Columbiana, Ohio. Humtown is a multi-generational family-owned business that started as a pattern shop in 1959. They have a history of making patterns from CNC, as well as sand cores and molds for the foundry industry. Over the past several years, Humtown has adopted and grown their additive manufacturing capabilities and extended those capabilities into the metal casting supply chain. Brandon joins the show today to talk about the history of the company, and we dive into the fascinating journey of this small company taking a leap into 3D printing. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, Stitcher, or YouTube. All right, Brandon, thank you for joining the show today. Let's get started, as we do with all of our guests, with just a little bit of background. When did you get into the additive manufacturing space, and can you tell us a little bit about Humtown?
Yeah, absolutely. Good to be here, Mike. Thanks for having me. Brandon Lamoncha, I've been with Humtown Products. I was basically born into the company. So, my grandfather started in 59 as a pattern shop making tooling. And, recently in the last 5 to 7 years was when we really started approaching additive. We didn't know where we wanted to get in. We thought pattern making and making tooling would be, a good fit for us, but we quickly learned that, using binder jetting and 3D sand printing was actually going to be our home. So, just like many people, you jump in thinking you know it all, and then we were quickly corrected and found our space.
And where was that first time that you saw a machine or kind of the company engaged in seeing the technology? Was it at the trade show? Was it online? Another company that you had been talking to?
Yeah, actually, the first time we really heard a lot about it was at a Rapid. They had a Rapid convention in Pittsburgh. I forget the exact year, but we ended up going down there, just kind of open, to the pattern making and the FDM market. My brother, he was our mechanical engineer, just graduated Youngstown State University, had a MakerBot. We were just, making little pieces and loose pieces and, fit ups and mock ups representations. And then while we were there was a casting track, and we heard a pattern maker give a talk about using X1. They didn't even have a printer yet. They were just, using the print service centers. And after seeing that presentation, my brother and I, we just looked at each other and said, that's where we need to be. That's really, we thought about it for prototyping and for, product introduction and part validation. But man, in the last 5 years, has it really changed from that?
And from your perspective as in the pattern making kind of tooling business, typically what would happen if you weren't using 3D printing? And can you just talk about kind of the differences between the two? Like traditionally, what are you doing? Kind of what was kind of the core business, and then why is 3D printing something that opened your eyes to a new or different opportunity?
Yeah, so coming from a tooling background, it always started with a 2D print, and we would basically sit down and we would lay that out, and then build basically, from a 2D print. Then when I started managing our CNC department, we started getting into 3D rendering, surface modeling, and we really thought that was, in the early to mid 90s, that was really, intense technology. But now to be able to take a solid model and then basically within a day, we can basically take that solid model, we can pull the inverse of that all in CAD and basically skip all of those steps, of having, going from 2D to 3D, and then having to glue up stock and then putting that on an NC machine and then whittling that away to make a tool. And then you still have to make a mold, or you have to take that to a core blower and then blow a core off of a core box. So, I mean, we're skipping, weeks, sometimes months. So for us, that's why it was so revolutionary, especially, an intricate, pumps and impellers and valve bodies. We're taking months of work sometimes and consolidating it into literally days. So that was the big aha moment for us, was saying 3D printing is really going to revolutionize this industry.
And were there particular industries within that, automotive, aerospace, heavy industry, that were more targets early on or more open to that sort of innovation?
Yeah. Ford was one of the first really early adopters of the 3D sand printing. I think they were using it for product development and really pushing out, that tooling build, because you're talking, like I said, 16, 18 weeks to produce tooling. So, and then if it's wrong, you have this iterative process of, cut it, try it, doesn't work, back to the pattern shop. Now, you can design 3 or 4 designs, print them, and do it concurrently. So you're basically able to cast 4 or 5 parts, machine them, and see which one works, without ever cutting a tool. So automotive was really receptive early on. I would say the second industry would be, any type of pump or, impeller, where you had this really complex, design that was always very hard to make, but then the tooling to get that shape was very intricate. And, if you didn't build those molds up just right, the pump would be out of balance. So the pump industry was actually probably the second real big adopter of the technology, especially when you have a pump system that's maybe 30, 40, 50 years old. There was no tooling, or it was lost, and they needed a replacement. They would scan it, print it, and have a really good replacement part quickly.
Yeah, and I always like to hear kind of what the story it was of kind of when you get your first hands-on experience with the machine kind of in companies. Like, what can you talk about a little bit about that period when you started, you saw it at Rapid, you kind of saw some presentations, and then kind of what are the next steps in terms of convincing other people or training up other people, talking to the machine vendors? Can you talk a little bit about that period of like, how do you get over that hump into actually making stuff beyond like, hey, this is a good idea, like we should be doing it?
Right. Yeah. It was not, it was not an easy process. These machines are, over $1 million. And in our industry, a good core blower or a good, molding line, is like a tenth of that. You know what I mean? So when you're trying to persuade, whether it's management at, at your company, or, in my case, my father, the owner of the company, to say, hey, we need to drop $1 million on this printer. And when we do, the business is going to come. Yeah, that's like field of dreams stuff. Like you don't run a business that way. So, we went after it very, collaboratively. We were blessed to have America Makes in our backyard. You know what I mean? So we could just go up and be like, hey, what are you guys doing? They're like, we're trying to get people to use 3D printing. We're like, hey, we're trying to get them to use 3D printing too. And then we kind of formulated this plan, and they connected us with, Jerry Thiel at the University of Northern Iowa. And basically they're like, hey, we're going to do this project. You're going to go meet Jerry, and you're going to be able to use this printer. I'm like, well, that's pretty cool. You know what I mean? I've never had $1 million, let alone, be able to play on somebody. It'd be like somebody saying, oh, here's my Lamborghini. I wouldn't even be able to drive somebody's Lambo, let alone go play on $1 million car, like a Bugatti or whatever. So hop in the truck, drive 10 hours out to University of Northern Iowa. Never met this guy in my life. And he came in and he said, hey, there's the printer. Let's go. He said, I have the printer, but I have no work for it. I have nobody in the industry. I'm a university. I'm not a sales or organization. So it was really cool because, I just started basically just jump right in, like, here's the printer. And it was not at all what I expected. And I think that's, one thing, an FDM, like, it made sense to me. Like, okay, you got this spool of stuff, it heats it up and it shoots it through. But when I was getting into binder jetting, it was really interesting. Like, this concept of lay this complete layer, cure it with the binder only in the selected spots, but then you got to go back in and, clean out all those spaces and nooks and crannies. So the first couple of designs, we had people that would design an entire mold without a parting line. Like, well, you can print it, right? And I'm like, yeah, you can print it, but you can't get in there and get the, the fugitive sand, or, you have to literally be able to go in there and clean that out. So it was quite the learning experience. And, there was countless stories like that where, we would print something, thinking, oh, it can be printed because of this technology, but it still isn't manufacturable. You still can't take it to the foundry and just pour it as is.
And as you kind of step through that process and learning kind of the design for the specific process, how much education did you have to do on the customer side to convince people to try this? Or was that not kind of an afterthought before, like just kind of get some parts out there regardless of whether you print them or they could be kind of traditionally made? Kind of how did that process evolve?
Yeah, that was the biggest learning curve, when do you use the technology? How do you sell it? Like, it's not, it's not the end all be all, it's a tool. And, we had customers coming to us and having these really crazy designs and, and they really wanted it, but then you cost it out and they're like, well, that's crazy. I can't even sell the casting for that much money. So how are you going to expect me? So it was a very, very steep learning curve because you're out there kind of learning on the fly because, we printed stuff and we had it. And we poured a few like turbo housings and simple designs, but, you're trying to sell something that you don't really even understand yourself. So you had to really partner. And we were very fortunate. We had some big OEMs that really wanted to be in this space. And, we would go to these small foundries and they'd be like, I just don't see it. I don't get it. And I don't think it was because they were afraid of the technology. I think it was just because, we couldn't even lead them to the path of when and where to use it. So luckily we had a lot of OEMs. So there was a lot of OEM, demand, a lot of pull. And then what that did was we were able to collaborate from the OEM side and then go out and they would fund projects basically saying, hey, let's just try this. And I'm like, well, you should really use tooling. And they're like, we understand that this may not be the case, but we have a budget to understand additive manufacturing, and we just want to try it in additive manufacturing. And then you would find ways through that process, whether there was a hybrid technique or whether full 3D printing or tooling was the route. But it was really the OEMs that, basically had that budget because they were trying to just get into additive manufacturing at whatever cost.
And I'm sure as you're going through that process, you're in this kind of nebulous state where you're kind of creating the business model as you go. You're not really a service bureau yet where you've got this kind of, okay, put in your CAD and you get a estimate back right away. It's more of a nuanced kind of per project. How do we partner? How do we kind of gain some learning, but also make justify like the use of the technology and kind of pull all this together. That was the thing.
Jerry, he was very, forward thinking in the technology, and we were trying to come up with ways that would, basically enable the supply chain and enable the foundries to embrace this technology. But you make one miscalculation, and even though he's not for as a university, it was a not-for-profit center, he still had to be sustainable. So he was trying to make something a little bit more palatable for foundries to be able to, but he almost ran out of funding because you make one miscalculation in these early stages and it can wipe you off the map. So we were really glad we were all able to work together and do it collaboratively as opposed to us just going out and trying to do it on our own, because I can easily see why if you jump too quick and jump into something, you can get over your head really, really quickly.
And is it similar to, I'm talking about binder jetting and kind of some of these early projects and even now that you're working on, kind of similar to other types of additive manufacturing processes where you're generally not going to be saving money in terms of printing the part, like apples to apples, either the material's more expensive or just machine time's more expensive. So you have to articulate kind of other value that could come in, whether it's speed or whether it's geometry or performance. Is it kind of similar in your case where you are selling on slightly different metrics than people are used to understanding or communicating on?
Yeah, at first, that's exactly what we had to do because when it first came out, I mean, the sand cost alone was like, in some cases, like 20x what a foundry was used to paying for sand, because it was screened and it was special, right? Same with the binder, same with all of the consumables. They all had this, arbitrarily high, cost. And I think what we did was we helped, with, University of Northern Iowa and some of our partners, we help to find regional consumables that would be at a much better price point. So yes, we had to try to sell, look at the complexity, look, we're able to take and consolidate 5 pieces into one. What's that going to save you, on the assembly line? And what's that going to save you, from a quality standpoint? What's the cost, what's the savings, for a 0 defect product if you can get there, so we were really trying to articulate, we can take and we can make you a better quality product. We can drive out a lot of labor costs. But now we're actually getting to the point, that we're almost, fully commercialized, that we can almost sell, anytime we have, a very highly complex small part, about the size that will fit in your hand, we can actually beat out conventional core making and assembly processes. So, we've done a really good job of driving down those consumable prices to a market that, it can be sold, basically in production.
And how has the adoption of the binder jetting influenced other processes in your kind of traditional business? Was there a difference in how you take in kind of data from the customer, whether it's CAD files or 2D drawings? As the need to go more digital with some of the additive tools influenced how you're doing any of the traditional processes that you've had?
Yeah, so we used to quote everything, off of, it used to be pictures and a 2D drawing. And I would say now, like 99% of everything that we quote, whether it's conventional or 3D, we're getting files. So, 3D printing has helped really, and I think all the industries have really done a good job of adopting CAD softwares, but I think that has been paramount, that we've started receiving digital, data packages, of the casting or the core box and of the tooling. So that's been very helpful. We also, I don't know where else I was going to go with that, but I really feel that, 3D printing and, this technology push has helped across the broad spectrum. So now we can bring it in, we can review it, and then we can help the customer decide, if you need something quick while you're in the tooling build, we can do prototype, then we can do bridge production, and then we can do dual path. So, if you go into full production and the tooling can only produce so much, we can come in behind it with 3D printing and kind of, give you the ability to produce more. But having that fully digital 3-dimensional CAD model has been helpful a lot across the whole spectrum of our business.
And has that forced you to kind of change any hiring practices or training processes when you're looking for people, or kind of building out the team to support the more digital kind of CAD heavy or design for AM heavy?
A lot of our pattern makers, we were kind of in a phase where most of them had been retired. We didn't get any of them to switch over at our company to being fully CAD, but we have customers that, I've been dealing with since I was, right out of high school. And, so 20 years ago, when I was just out of high school, we would work, on designs and drawings. And now I'm going into those same foundries, and that same designer is there. And now he's sitting at the computer, he's giving me CAD renderings. And, so there has been that transition. But yes, a lot of the new designers that are coming out of, of the universities, that have, a lot of CAD training and CAD ability, they're working side by side. So like at our company, they were working side by side with our pattern makers, so that because they couldn't really be useful in our industry right out of school, they needed that side by side. So they would run the computer, but we would have a pattern maker giving them, they were feeding into them. So it was kind of cool to watch. And that's kind of how my brother, who is a really gifted CAD designer, he was working alongside of a pattern maker to get that tribal knowledge, So that was kind of cool to see. But now we're seeing less and less of that because a lot of them have been retired. But I would say right now, I'm seeing some of the best designs and some of the best CAD modeling coming out of our customers and coming out of OEMs that I've ever seen. So it's promising.
That's great. And I always like to ask our guests kind of what's a typical day look like for you and kind of at the facility, just to give people kind of an inside kind of look of what's going on and what they might expect inside of a place that's using additive manufacturing.
Yeah, so I would say for me, it was kind of funny. I was at lunch today with a colleague that I had worked at when he was at GE's Center for Technology Advancement there in Pittsburgh. He's since moved on, and we were kind of laughing because this pandemic, everybody's been working from home, and he's like, you've been working from home before it was cool. And I was like, yeah. So about 4 years ago, because of this technology, that's been given to us to be able to use, I was actually able to move and work remote. I do a lot of traveling. Obviously, I'm in sales and business development, and I'm out looking at technology. So I travel a lot, and when I'm not traveling, I can work from a home office because everything is done, digitally now. Whereas if I had, in the days of CNC, I had to be in there designing, working side by side with the machinist, looking at the product. Now with this digital world, you can almost work from anywhere. And a lot of my customers don't even know that I live in Southwest Florida, other than my tan. So, it's really helpful, for me, because it allows me to move about the country or move around the world, and I can quote things. I work basically from my laptop. I'm getting files in daily. I'm doing the quotes, I'm reviewing them. I get purchase orders. I process those. I upload those files that are ready to print to a database. Our team pulls them down. I started out, I was doing a lot of the build boxes, before we grew to this level. So my job is beautiful because I can do it remote. I've always been able to work pretty much anywhere I get good Wi-Fi and VPN. Now, you take a step back and come into our facility, we've about 100,000 square foot now. We have two facilities. We have our conventional facility, which is where we started. And then about 7 miles down the road, we have about 100,000 square foot of dedicated additive manufacturing space. We have offices, but it's mainly production space. And if you walk in there, you're going to see 5 of X1's largest, S-Max 3D sand printers working. One is a customer's. They placed it there because they didn't want to necessarily have to go through all the learnings. And they said, let's place this here, have dedicated capacity and, your expertise. And then the other 4, we basically run, for Humtown, and we're producing parts day in and day out. We have about 12 people that work in that facility. They're basically feeding those machines with consumables, harvesting parts, cleaning parts, packing them out. We have 2 docks there. So what I would say is different about our facility is every week since October, we've shipped a 53-foot air ride trailer of product to Mexico. You're going to see tonnage. We printed 800,000 pounds of sand in December. So we're going through a lot of material. And that's what I think people don't realize is that, and we have production jobs that are up to 20,000 EAU. So some of these very small hydraulic manifolds or valve bodies, we're printing, in production for customers. So, and that is what is a little bit different about our facility is you're going to see, a lot of product going through there.
And did you find kind of with the pandemic, kind of any disruptions either to kind of your supply chain or customers that you'd seen be disrupted kind of come to you with new projects or kind of the need to evaluate different manufacturing options?
Absolutely. We did not have any real major disruptions other than ours would be more like weather related, so like when there's blizzards and snowstorms, we couldn't get sand and raw material resins in. But as far, everything that we source is really domestic. Some of our clients came to us and, with them buying tooling out of China, and there was entire provinces shut down. They weren't able to get tooling, to continue to develop. So this was an opportunity for us because we went into full alpha and beta testing and trialing, of products, of castings for our clients. So that was actually a really good opportunity for us. And for them, they typically would have design froze, I believe, in March. We gave them complete design flexibility all the way until October, until we started printing. And then they've had a few iterations, even mid-process. So I think it's opened their eyes. I wouldn't be surprised if every development project for that customer goes at least into alpha with 3D printed molds and cores, because it just gave them so much flexibility. It enabled them to let their design engineers continue to work on the product so that they have the best possible product to enter into the market. And at the end of the day, that tooling that they would have bought versus the cost of all the printed molds and cores that we sent was about the same. So, that tooling, after they use it for prototyping, they throw it away. So I really feel that this disruption and this pandemic is going to open up opportunities for us that are going to be, going on much longer than this pandemic will ever last.
And on that front, I mean, you've kind of had this evolution into using the technology starting in university. Now you've got a number of machines at your site. Kind of what's always on your radar to continue to improve the process? Is it kind of scaling it for more machines, bigger machines, different materials? You've talked about kind of optimizing some of the material costs, but are there things you're looking at kind of on a continual basis to kind of improve the process overall?
Yeah, absolutely. We need to continue to push the machine manufacturers to get a machine. We need to drive the cost down, and as the cost goes down of these machines, we're going to be able to open up opportunity. I think I was researching, I think the metal casting industry in North America alone is $44 billion a year. So, we're just scratching the surface. So the opportunity is out there. I feel, we really need to optimize the equipment. If we can make them faster and at a lower cost, I really feel that we're going to be able to really penetrate that market. This is the way, molds, it's going to be a hybrid. It's not going to be all additive or, it's going to be a hybrid process. They're going to still continue to use, automated molding lines, but they're going to incorporate 3D printed cores into that to get the best product possible. And I think there's huge opportunities out there, and I'm excited, to see, because now that the design engineers at these OEMs are seeing the capability of what can be done with additive, now the sky's the limit. When they see that they can get better performance or better swirl or better, horsepower or more, when they see that they can get better performance, and reduce draft and backdraft, it's just going to really open up the opportunities for casting. So very exciting time.
Is it still pretty nascent in terms of other people doing similar things to you guys, as having the X1 systems in their building tools, building patterns for the general industry? Is it still pretty new overall?
I would say it's being adopted more and more. I remember when I started this 5 years ago, I went in to a meeting and talked about, being able to get castings without tooling, and you would have swore I had a third eye. People could not believe what I was talking about. They did, but now just about everybody I talk to has either heard of it or understands the technology. But yeah, I'd say we've done a good job, the American Foundry Society and America Makes, and I think we've done a good job of educating. I think we just need to take it to that next level of full, it's not top of mind, in every situation. I think so many people are so complacent in doing things the way that they've been doing it that sometimes they just forget to reach out or lean into that next space. And I think we just need to keep it top of mind. And I think the adoption will continue to grow, but I would say, there's not many people getting into the space, other than like OEMs. I'd say us and a few of our competitors have we have a pretty good handle on the service industry and the print service centers. I think now what you're going to start seeing is the adoption. More and more foundries are going to put them at the point of need. Will still be needed as the overflow. I can tell you almost every customer that I've helped install a machine and consulted with and had, them purchase a machine and put it on their site, they become my biggest customer, because once they see the opportunity, they fill theirs up crazy fast, and then they're coming and leaning on us for backup support. So people always ask, why would you go into consulting and help set up, these your customers with printers? And I said that they become the best customer, because when they understand the adoption, it pushes us into more of like a partnership, or, and we just become their backup. So it works really, really well.
And how do your customers kind of define success when they're kind of working with kind of the technology? Is it the speed that they always kind of go back to, or what's the ultimate thing that they're looking to you to deliver on?
Yeah, I would say, speed to market, is the biggest, and it's a huge competitive advantage when you can develop and continually develop new product. like I said, some of these programs, I mean, they would spend well over $1 million in tooling. So you can imagine, they don't do that unless they have to. So now when you remove that constraint, that $1 million tool up constraint, and you say, oh, well, we just want to tweak the water jacket, or we just want to tweak the intake port, for these engines, now you make a design change, you print a new core, and you're able to test it in real time. So I feel that, I just see this really enabling them to make more consistent and quality improvements, more often.
And for those kind of listeners who are kind of maybe new to the industry or kind of dipping their toe in and trying to learn as much as they can, kind of what advice would you share as kind of someone who's been in and around the additive manufacturing space? Like what sorts of careers are out there? What kind of sorts of skill sets are kind of most in demand that they should maybe work on to help with kind of building their skill set into the 3D printing world?
Yeah, I would focus on, the ability to design. You know what I mean? I feel like the machines are pretty robust and pretty easy to operate, so I don't feel like you need to spend a lot of time, being real technical. I mean, it's really process. I would say process engineers and really understanding, because I was just at a facility today. They had multiple machines, and no two machine. This is so new that when you go in somewhere, you're not just going to be handed a book and say, here's what you have to do. So you need to be able to understand how to develop process, have, good design fundamentals and understandings of, software. Even for myself, I wish I had more time to dedicate to running CAD programs and I would like to be a better designer, and have more time, on the tube. And I think, that's where we're going to see some of the biggest breakthroughs and some of the, the most vital people to an organization, I feel, are going to be the ones that can really understand how to develop and maintain a good, solid process and, really push the limits of design. I think that's the two areas that I would hone in on myself. Obviously, there's so many, like myself, I'm not extremely technical. But I mean, just understanding opportunity and, networking and, and really having that troubleshooting mentality of, how can we solve this problem using a new tool, and really wrapping your head around, opportunities. And it's fun. I mean, that's the biggest thing, that I've learned is this industry and networking and seeing, different products and different machines, that they can have different capabilities. So it's really fun to just engage and see all that. But those would be the two that I would really hone in on, is design and process.
For sure. Yeah, I think that's great advice. So Brandon, thank you so much for joining the show today.
Yeah, absolutely.
Hopefully see you in person sometime soon, hopefully at AMUG in a few weeks. And
absolutely. I'll be there.
Awesome. And congrats on all the success that you guys have had, and look forward to kind of seeing more over the coming years.
Sounds great. Thanks, Mike, for having me. Have a great weekend.
Thanks so much.